Okay, I should be live. But am I? There we go. Old timer confirms it. Okay. Okay, here's the lighting. Oh, let me start the recording. And the recording. Here you go, Chad. This should be the lighting. Guaranteed. Live. Recording reminder. Yes, I am recording. All right. So, does this really count? Is it on the shelf? Does that really qualify as being on the shelf? It's a good eye. You notice the tube in the back. Yeah, okay, so I'll I'll wait. I'll wait for a few more people to show up. All right. Okay. All right. Well, let's get started. Zapfan's here. Hey, Zapfan. Thank you, everybody, for hanging out with me tonight. So if you're wondering what it is that you have stumbled into, this is going to be the live question show where you're going to hammer me, pepper me with your questions about space and or astronomy. And I'm going to do my level best to answer your questions. A few ground rules. And that is, number one, I try to give emphasis to the people who've never had a question answered before. So go ahead, put your questions into the YouTube comments, and Zapfan will tag them into the database. And he is backed up by by his AI buddy, and that will help make sure we get all the questions handled. And then I will look through and look for people who've never had questions answered before and start with them, but not end with them. Now, this whole thing lasts about 2 hours, so we will go for 2 hours. It's 5 o'clock now. We'll go till 7 o'clock. Second thing is, keep in mind that I am a journalist, not a scientist, so I cannot provide any additional information or unique opinions about various concepts in space and astronomy. I can just report on the sort of the scientific consensus, which may sometimes sound like I'm providing an opinion, but I'm not. I'm providing the sort of, I am normalizing the scientific consensus. So just keep that in mind. If you want, like, my distinct opinion and how that differs from Avi Loeb, for example. Third, which is that we get a lot of the same question over and over again. And that's fine. We love to answer them, but just keep in mind that, if I haven't answered your question, it might be because that's a question we've answered so many times. And, I get people going like, oh, that question again. So I'm looking for the unique stuff. I'm looking for the stuff that maybe we haven't answered ever or in a long time. Okay. Raise my mic. I can't raise my mic. This is as raised. Well, can I raise it? Yeah, I don't want it to be too in the... There you go. Okay. All right. So first, I guess I should absolutely address the water heater in the room, and that is this guy. So that is an 8-inch Skywatcher Dobsonian telescope, aka a light bucket. And I was having a conversation with a patron about 2 weeks ago, and we were talking about telescopes, and they were asking me, or I was asking them how they got their telescope, because it was a pretty cool telescope. And they said, oh, I just went on to Facebook Marketplace and did a search, and somebody was selling this exact telescope, and so I bought it. And I was like, oh, that's really good advice. I want to see sort of what the state of the telescope market is in my city. So I went on to Facebook Marketplace, and there was a bunch of telescopes, and then there was an 8-inch Dobsonian, which is like my dream telescope. That is the one telescope that I've always wanted to own. It's a light bucket. It's a gigantic, very capable telescope that allows you to see, the planets, the moon, and other faint deep sky objects. When it comes to telescopes, bigger is better. And so, and the price was really reasonable. He was he was looking for about, all in, it would be about a third of what I would pay if I bought it from Amazon with the shipping and the taxes and bought it new and all the accessories. So I was, no brainer. So I contacted the guy, went out, picked it up, brought it home. Now our weather has been crap. It's actually clear right now. And so, I'm kind of tempted to just cancel the live show and go out and use the telescope, but no, I won't do that. And the moon is up. So stupid moon ruins everything. But we looked at the moon 2 nights ago, and it was hilarious because it's so bright that you're like, one eye is like light adapted and the other one is dark adapted. And it's very confusing to walk around. Like you look at the moon and then it's like a laser beam in your eye. Also looked at Andromeda and looked at the double cluster in Perseus and a few other objects that I was able to get before the weather came in. So, but this is it. And so my hope is I'm going to take that telescope out and do some sidewalk astronomy where I just stand outside of a movie theater or stand outside of a concert and just let people use the telescope to look at Saturn or Jupiter or Mars or whatever. So I'll let you know. Maybe I'll record some episodes of that. Like for me, my favorite experience is that moment when you are present for a person seeing Saturn through a telescope for the first time with their own eyes, that you get to experience. They're just like, what? And then like, this can't be real. They say like, this can't be real. Is this a picture? Is this a photograph? What's going on? No, it's really Saturn. It's that light up, that little orange dot up in the sky. That is Saturn. So yeah. And people see like much, there's much larger telescopes. Like you can get a 10-inch Dobsonian. People own 12-inch Dobsonians. People own 20-inch Dobsonians. And the problem is that, they're better, but they're bigger, heavier, harder to move, harder to put into position. And the 8-inch is sort of the perfect size to lift the thing up, carry it outside, look through it. Yeah, the 8-inch is sort of like the perfect. It's already like it's got 2 handles on the side. I have to pick it up. It's very heavy to move it outside. So that's the perfect size. I do not recommend going with a bigger telescope unless you really know what you're doing. You've got a good setup. You can deploy the telescope very easily. They're a real pain to move around. This is the right size. You can stick it in the back of your car. Go to a dark sky site. It's the way to go. Okay. Now let me see what the questions are. Kim Barron. Talk about the great filter and how it had to be 100% effective. What if there are multiple filters and there's no way for a civilization to avoid them all? It doesn't need to be one specific filter. Right. So in the original telling of the great filter, the sort of the idea about the great filter is that there is in the past, there were events. Things that were very complicated required some kind of leap of evolution. The formation of the first life form, the formation of multicellular life, going from, from the oceans to the land, the development of the brain, the development of a technological civilization. There were these discrete steps that you can imagine that there is like, maybe there's a 1,000 planets. And on those 1,000 planets, only 1% of them actually produce a multicellular organism. And then of those that go on to produce multicellular organisms, only 1% goes on to produce intelligence. And so these are filters, that they are filtering down the number of life forms at each step. And that if you can kind of go back and identify what all of those important steps were, then you can sort of get a sense of how this sort of, the odds narrow all the way to where we are today. But we are at a step in our, like, the evolution of humanity and our sort of place in becoming a solar system spanning and eventually a species that's gone on to explore the entire cosmos. And that there are filters you can imagine that maybe very well be in our future. That there is has to develop space flight and be living on 2 planets, has to be able to escape the solar system, because if we don't, then the sun will consume us all. And so that's the assumption, is that you're going to have all of these different filters. And so, there's kind of 2 possibilities exist if the great filter is correct, right? That if there's a whole bunch of civilizations that were out there and that number has been winnowed down to the point that we don't see anybody out there, one possibility is that the filters are in the past, and that there was, let's say, 10 filters, and we have passed them all. And now it's open, it's clear skies in front of us, that there are no filters remaining, that there's no reason why we won't naturally proceed to become a galaxy spanning civilization. So that's one possibility. And that, and if there were multiple civilizations out there, then you would expect that there would also be some of them as well. And so the question is, where are they? Because as soon as you become a solar galaxy spanning civilization, that means you're kind of everywhere. So the other possibility is that there is either one or multiple great filters, and that those filters are 100% effective, that we may get past the next one, we may get to having a city on Mars, we may get the next one, but we won't make the next one. And nobody's made the last one. That the filter in the end has filtered out every single life form from becoming a galaxy spanning civilization. And that's why we don't see anybody in the universe, is that everybody tried, right? Life formed on all these worlds, multiple cellular organism evolved in all these worlds, intelligence involved in all these worlds, but less. And then society formed, and then technology, and then space flight, and then solar system spanning civilization. And by that point, everybody got filtered out. And so that's why you can see it as many filters, or you can see it as one filter, that there is one filter in the future of us. Like, obviously we made it so far, but there is the filter out there in front of us that is 100% effective. And we will eventually crash into the filter. And we will also, just like all of the other civilizations out there, will fail to colonize the galaxy. So, that idea that there's something waiting for us that's 100% effective is so terrifying, so sort of gothic horror, eldritch horror to me, that I just say, no, we're alone, or we're the first. So there is no filter, and we're about to colonize the galaxy. Phil, aka Thunder UK, did you enjoy the Terra Invicta game? It was fine. I didn't play it as much as I had hoped to. The idea of the game is that it's the strategic element behind, like, XCOM 2, where you're getting aliens are coming and starting to take over chunks of Earth, and you're trying to fight against them with political and economics and building armies and so on. The thing that it doesn't have is the tactical game that I really enjoy from XCOM. Like, that's my preference, is the tactical game. And so XCOM has this version called the Long War, and they did the Long War for XCOM 2. And that was like my perfect thing, where you're both dealing with the strategy of the alien invasion and trying to build a power base, but also you are fighting tactically against the aliens in different zones, gathering gear from your encounters, researching it, developing better equipment to be able to fight them and sort of stay ahead on the tech curve from the aliens invading you. So Terra Invicta was fine, and I'm sure if I'd like spent a lot more time really learning how to play the game, I would have enjoyed it more, but it just didn't kind of grip me in the way that XCOM does. Ed Skeptic. Why are certain astronomers saying that we are in a void when we've been told in the past they were part of the Virgo supercluster and Laniakea? So I'm not sure which astronomers are saying that we're in a void, but that is not the established scientific consensus. The consensus is that we are part of the local group. The local group is part of the Virgo supercluster. The Virgo supercluster is part of the Laniakea supercluster. That we are embedded inside a gigantic galactic structure, and that there are voids outside of that galactic structure, but we are not part of it. And it might be that you are confusing our presence in a region called the local bubble, a region that has strangely lower density than the surrounding Milky Way. And it's believed that this is because a bunch of supernovae went off in our environment over the last few million years and sort of put out all of this material and has actually decreased the density of material in our area. So maybe that's it's a sense of scale. Like one thing is a few thousand light years across the local bubble, while the other thing is hundreds of millions, if not hundreds of millions of light years across the size of these cosmic voids. We actually did a great series on cosmic voids on Universe Today over the last week. So if you're interested, we've got a 7-part series on cosmic voids written by Dr. Paul Sutter, who is a astrophysicist who studied cosmic voids. So definitely check that out. Ending soonest. I think your perpetual out that you are only a journalist is unbecoming. Journalists about politics don't say, I could not possibly have an opinion of my own. So I think you're super wrong. And that is that I think that, what you see on the internet with journalists espousing opinions is often done badly. I think obviously as a journalist, we have opinions, right? And especially when we have opinions about things that we are required to participate in for democracy, right? Like as a Canadian citizen, I have to vote for my government. And so it's my job to build up a level of expertise in the policies of the various parties in my country so that I can form an opinion, so that I can have a vote. But a lot of what you see on, say, talk TV and things like that is punditry. People just spouting their minds to fill airtime, to make advertising revenue for the network. And they're not actually bringing any value. The value is brought, it's very low grade quality. The value is brought when somebody, in as impartial a way as possible, evaluates the facts, uses reason, and attempts to try and uncover truths about reality. And that, that is not as exciting, not as entertaining. It's not as gotcha. It is, in some cases frustrating when the information contradicts other information and you don't kind of know which thing to believe, but you trust in the scientific process and things move forward. And so when you look at the various things that I address, right? I talk about planetary science, space exploration. I talk about astronomy, astrophysics, black holes, neutron stars, neutrinos, particle physics. Like it goes on and on and on. Cosmology, inflation. Like I probably cover comets, asteroids, Mars, Saturn. I probably cover 100 different topics. And that the new information, where the cutting edge of all of this stuff is each one of those things, right? Why did plate tectonics shut down on Venus? What is the interior structure of Jupiter? What is the compelling evidence that inflation is a reasonable explanation for what drove the Big Bang? And on and on and on. That people who have dedicated their lives to this subject, who have gotten their bachelor's degree, gotten their master's degree, gotten their PhD, done work postdoc, and then researched for decades using some of the most powerful instruments and observatories that humanity has ever created, they're the ones who are right at the bleeding edge of every single one of these topics, and that they are making progress in those things, and that they are, and this is going to be the controversial thing, they are the ones who are qualified to have an opinion because they did the work, that they went to school, that they use the tools, that they are being peer-reviewed by other scientists in this thunderdome of scientific academia. And that for me, I am a generalist, I am a journalist, I am just reporting on what things people have found. And so that if I go and espouse an opinion about string theory or multiple dimensions or anything like that, then I am sort of foolishly taking on the mantle of saying, even though I haven't done all of the work, I know as much as they do. And that's ridiculous, right? Like that's bonkers to think that you haven't done the work and yet you know as much as they do, or even have an original opinion that goes above and beyond what they've done. That the very least you can do is match the work that they've done in whatever specific field. If I want to have an opinion about exoplanets, I've got to go and get my PhD in exoplanets. If I want to have an opinion about cosmology, about which theory I think is the one that's best, I need to actually be able to do the math and look at what the math is telling me to be able to understand the consensus opinion. And that to jump right to, I don't really know very much, but I have an opinion, is very short-term thinking. And this is what's got us into this problem, this situation. And so, I think it's perfectly fine. It is not unbecoming of me. I think that it is a standard that I wish more people would hold themselves to, is to say, hey, I don't know very much about that. So I'm going to withhold judgment. And instead, my shortcut is I'm going to trust the scientific consensus. I'm going to assume that the people who have dedicated their lives to studying this thing, who battle and fight with each other, who are watching for anyone to make a mistake so that they can pounce upon it and highlight it, they are probably the ones best to listen to for this opinion. And that I can, and that the thing that I should do is spend the time to understand their opinion so that I can communicate it and I can participate in it, right? But not think that, to not be so, to think that I have a better idea. It's crazy. And, I think we all have expertise in various fields. I don't know what you're good at, but my guess is you're good at, my guess is that you're the best in the world at a few things. It could be speed running a video game. It could be doing some kind of craft project. It could be cooking something, whatever it is. It could be knowing your town. And that anyone who comes, who is like on the other side of the internet, is playing GeoGuessr and is looking at pictures of your town and is espousing opinions about your town, you're going to go, that's ridiculous. You have no idea what you're talking about because you haven't experienced what I've experienced and formed the opinions that I have through expert practice. And so, no, I think I would place a lot of our current crisis in people not trusting experts, and this sort of like distrust of authority, on not distrust of authority. To hell with authority, right? Let me be clear. Expertise, the sort of attack on expertise, is coming from people who have decided that they're an expert at something without actually doing the work to become an expert. So no, I 100% completely disagree with you. Okay. Did that question get answered? Wow, it wasn't even a question that the system grabbed. Okay, no problem. Okay, some 3i Atlas questions. Robin Stobie, is there a chance that 3i Atlas breaks up like Shoemaker-Levy Comet? I don't think so. Right now, it's already past its perihelion, the closest point of its orbit to the sun. And so if it was going to break up, it would have broken up. Even though it was on the far side of the sun and it's lost in the glare of the sun, there's a bunch of spacecraft that are watching the sun. They block the light from the sun and they're able to watch the movement of the comet. And so it hasn't broken up yet. And this is like the danger zone. And now it's out the other side of that. And so, no, I don't think it's going to break up. Gino Monet, Fraser, do you know of any good budget scopes up to 800 euros? That. So, if you've got, it's like, there's two options. Like now my opinions about telescopes, after telling you that I don't have opinions, but this is my personal experience. So, at this point, there's kind of two paths that you go with getting a telescope. One is to do observational astronomy, that you just want to look through the eyepiece and look at objects in the night sky. And for that, you want a Dobsonian telescope, a light bucket, something that moves quickly, allows you to point at different objects in the sky, and you can look through them. Because, like, in general, there's about 5 bright objects that you want to be able to see: the moon, Mars, Venus, Jupiter, Saturn, maybe Neptune and Uranus if you're brave. And then and you can even do that in light polluted sky. So even if you live in the middle of Manhattan, you can get a Dobsonian telescope and be able to see the rings of Saturn and the moons of Jupiter and things like that. They're so bright. And then the other tool is, if you want to go beyond that and see all of the other stuff that's in the sky, then you want to go with some kind of automated telescope. And the one that's really great right now is the Seastar. This is the one that costs about $600 and takes really great images of the night sky. You can be, I shared a picture of the Comet Lemon that I took, 30-second exposure. Like, it's crazy how good this is, and how taking a picture looks, you're not seeing it with your eyes, but it still is kind of amazing that you're able to get pictures of these things at all. So in general, you've got to decide, do you want to take pictures of things? If so, go with the Seastar. Do you want to see stuff with your own eyes? Realizing that if you live, if you're saying euros, then I'm guessing you live in pretty light polluted skies. Then you may want to, be careful about trying to get a telescope you can use with your own eyes, because there's a limited number of objects that you can see until you get in the car and go somewhere dark. Matt Squirrely, Project Hail Mary, yes or no? Yes. Yes. Very good book. And now there's a movie coming out. 100 times yes. Grumpy British Bean. Grumpy British Bean. We know space missions can take years and years to develop, and some even longer to reach their destination. How old is the technology in some missions compared to today? Is James Webb already out of date? So there are missions that are operating that are almost 50 years old, right? Look at the Voyagers. So, the technology that was developed for the Voyagers, which launched in 1977, was probably 10 years earlier than that. So it was probably developed in the 60s, and it's still operational. So that's kind of amazing. Is James Webb out of date? So not exactly. The way this works is that when computers go into space, they are susceptible to cosmic rays. And the cosmic rays can do damage. They can flip bits on RAM. They can sort of fry components. And they're more susceptible. They're more susceptible the thinner the transistor size. So on our modern phones, computers and stuff, we're down to like 3 nanometers. And those are very fragile in space. So instead, you want to go with older technology, stuff that is in like 10 nanometers, 12 nanometers, and that a lot of this stuff has been proven to work in space. Now, it is not as advanced as, like James Webb has less computing power than your phone, probably. But if you sent your phone to space, it wouldn't work very reliably for very long. And so people who are working on space missions are less concerned with the latest and greatest, the hottest technology. Their concern is this thing going to work for the duration of my mission to fulfill the instruments that are attached to it? It's more about the size of the LCD that's attached to the telescope. Is the computer fast enough to be able to handle that? Now, when you look at the largest camera ever made is on the Vera Rubin telescope, and it's a brand new telescope, right? It's a gigapixel camera. No one's got a camera that big on their phone or on their computer today. Maybe they will in 10 years. I don't know. But no. So in general, it's sort of like it doesn't make sense to ask if the technology is outdated. The technology is space hardened, is proven to be reliable in space, and that's what people are looking for. Now, there's other stuff like CubeSats, smaller satellites that are designed to only work for like 6 months, a year. And in some cases, they actually use repurposed cell phone components to be able to do that. So, but like in general, the thing that's most important is the reliability of the computer. Chris Nelsonels, is there any astronomical events in the near future that you would recommend breaking out the backyard telescope to share with my kids in the near future? I'm in Washington State. So like right now, you can see Comet Lemon, and it looks great. So, and like literally like stop watching this, get the telescope out and try to find Comet Lemon if you've got clear skies right now, because it'll be going down in about 2 hours, and you'll see it to the west. And it'll be gone. It'll be sort of faded away in the next week. So I would definitely go and take a crack at that. CV Tabak Man, what has happened with Planet 9 lately? Nothing. We're waiting for Vera Rubin. Like, so far, people have been unable to find Planet 9, and the telescope that is going to be purpose-built to find Planet 9 is going to be Vera Rubin. So we're about a month away from it going into its full operations. And when it does, we'll be getting tons and tons of data. We'll be getting lots of new asteroids. It's expected that we'll find 100,000 supernova a year. And we should find about, like, we're going to find probably 10 interstellar objects a year with Vera Rubin, and we will probably find Planet 9. If it's out there, Vera Rubin will find it. Sid Vicious, I notice you're more optimistic about the Chinese space program recently. Why is that? Is that a result of the US government budget cuts in space exploration? I don't think I've been more or less optimistic about the Chinese space program recently. I think, I would have to go back and look at my reporting, but my experience with the Chinese Space Agency is they have a long-term plan. In some cases, they have a decades-long plan, and they have a bunch of milestones, and they hit their milestones. It's kind of boring, right? That, they're going to they built the Chang'e series that was going to the moon. They retrieved samples from the surface of the moon. They retrieved samples from the far side of the moon. There's going to be Chang'e 7, Chang'e 8. Chang'e 8 is going to do 3D printing and in situ resource utilization on the moon. They've got the Tianwen. They've got to Mars, as well as now to an asteroid. They've got their space station, and now they're preparing their plans to bring humans to the moon by 2030. And they've got 2 new versions of the Long March rocket. They've got their, I forget the name, the lander, Mengzhou. Anyway, they've got a lander and they've got a crew capsule, and both of those are now in testing. So everything is proceeding according to plan. Which has been laid out. Like, you can go to various Chinese websites and Chinese state-run websites, and you can download their long-term plans for sending missions to the moon, and they just hit their milestones. So that is completely independent from what's happening from the United States, and it's not like what's happening in the United States is changing what's happening in China. China is just following their plan. And the United States is in a state of uncertainty right now. And it's a totally different thing. They are independent vectors. They are not related to each other. Now, I think that they're going to become more related to each other as, obviously, people are getting concerned that China is going to get to the moon before the US returns to the moon if there's some problem with the Artemis 3 mission. But that's like an artificially engineered space race where none exists. The space race was already won. The US got to the moon 50 years ago first, put the flags, had the footprints. That's over. So there is no new space race to the moon with China. So no, I don't think my reporting has changed at all. KGS, did anyone steal your C-Star telescope? No, when the telescopes are missing, it means they're in use. It means that I've recently had them out and I was using them and I just didn't put them back. Billions and billions of stars. Do we finally know what the little red dots are? No. Magic Game Dev. There are so many fake photos of 3i Atlas. Can you share your favorite sources for real ones or even your favorite pictures? Yeah, so there are a dozen different observatories that have taken images of 3i Atlas, and there have been a bunch of press releases that have been associated with that. So we've gotten images from Webb, we've got images from Hubble, images from the Gemini North Telescope, and then a bunch of other telescopes as well. And so I like this is not going to be a very satisfying answer, but it's that you want the ones that are associated with actual research institutions. So you want images that came from observatories. And so then you're like, well, how do you find those? And so the one answer is that you follow lots of different observatory websites and keep track of their news, because they will post new pictures that they've taken as news releases, and they'll like, oh, we've detected this new thing about carbon dioxide in Triatlas or whatever. And then another good source is to go to archive, arxiv.org. And this is the preprint location that astronomers post their research. So they will write up a science paper and then they will post it into archive. And there's about 100 research papers that are posted every single day. And there's like a requirement to be able to even post to archive that you have to be part of a legitimate scientific institution. So you can be NASA, a university, a research institution, something that is recognized and certified. And so you can consider that stuff to be fairly trustworthy. But the easy answer is that you just follow Universe Today, which is the website that I publish, because we are very careful and very studious about making sure that the stories that we report on have legitimate sources. And if there's cool new pictures of 3i Atlas, you bet we're going to post them. And then, of course, every time we have more interesting pictures, we're going to talk about them in Space Bites, which we do here on the YouTube channel. So you can replicate the work that I do and go back to the same sources that I do, which is totally legitimate. Or you can just wait for me to do all the hard work. Dan O. If Earth had rings, what latitude would you want to live at for the most dramatic view? So obviously you wouldn't want to live at the equator, because if you lived at the equator, then the rings, you'd be seeing them edge on, and so you just wouldn't see them. So you'd want to be north or south of the equator, and you'd want to be you wouldn't want to be so far north that you would be like seeing them down towards the horizon. So probably like mid latitudes, halfway between the equator and the poles would be good. Of course, if you did see rings orbiting around the Earth, that would be very, very bad, because that means that an asteroid came too close, or a planetoid came too close to the Roche limit of the Earth, was torn into pieces, and now those pieces are orbiting around the Earth, and they're going to enter the Earth's atmosphere and rain fiery death down from above. So you would want to be as far away as you could from the equator if you saw that the Earth had rings. It's Skeptic. How can real science content creators combat the tsunami of AI slop science channels? You can't, right? Like, especially because YouTube is a willing participant, a enthusiastic partner in AI slop. So there's nothing we as creators can do apart from focus on being better, right? That the hope is that someone's going to watch an AI slop channel and they're like, oh, this is all garbage. I'm sick of this. Is there anybody who's like doing good work? And then they'll find a channel like mine, or SciShow, or PBS Space Time, or Scott Manley, or Marcus House, or Cool Worlds. Like there's a ton. Smarter Every Day. Like there's a ton of good science channels. And then they'll understand the ecosystem and they'll stick with them. And so one by one, people will have become so frustrated by the low quality on YouTube that they will switch over to high quality channels. I think like we did the 3i Atlas sort of comprehensive 3i Atlas video. And we had a ton of people saying, like maybe 100 people said, wow, finally somebody is doing a good science-based coverage of this object and not just the clickbait AI slop. And that was, that was great because that's exactly what we were looking to do. We wanted to just blow people away with the level of reporting, the providing the sources, do a good job. And so there's nothing we can do. Like, how could we do it? That YouTube is like literally in the YouTube creator studio, it has AI slop dripping from every corner. It is encouraging me to make AI slop. It is making it easier and easier, providing me tools to slop it up, to get sloppy. So, and that I am specifically resisting incorporating AI into anything that we do because clearly there's going to be a backlash. And, like for starters, it's garbage. But then also, I think people are going to be looking for legitimate sources. So no, I think you just keep on keeping on and hope that in the end, this is just a fad and it doesn't work out. And if not, then we all get shut down because we can no longer afford to stay afloat. But like, I find YouTube less entertaining now. Like I've been like, I don't use any social media really. I don't spend any time on Instagram or Twitter or Blue Sky or any of that. YouTube is the one that I am overly addicted to. And even now I kind of like look on YouTube and I'm like, ugh, this is just going downhill. It's like celebrity gossip and AI slop. And it's getting harder and harder to find channels that I really like. Nui Takui. I've seen a lot of creators saying that the first country to establish a base on the North Pole of the moon will essentially control the moon from a resource extraction perspective. That's not true at all. If you set up a base on the moon, you've got one tiny little base on the moon, and that anyone else can come and set up another base on the moon and extract resources. And it's not like you can defend the moon from your little base on the moon. And if you do try to defend your base on the moon, you're going to have to deal with the real world implications down here on Earth for you being a jerk over on the moon, right? Like, So, as long as a country has obligations and interactions here on planet Earth, it is beholden to the international community. And so it can't just act like a jerk and expect to get away with it forever. So, no, absolutely not. And even if you did get to the moon, and even if you did extract resources, you would be doing that, losing enormous amounts of money for a very long period of time. So no, we have nothing to worry about from somebody planting a flag on the moon and saying, I own the moon. The Outer Space Treaty, which all of the nations that are relevant have signed, says you can't own the moon. So they are violating the Outer Space Treaty. And that is a treaty signed by them here on planet Earth. And that there is an international community that will hold them accountable, especially if they are a military threat or are running away with some economic discovery on the moon. That, as long as they have banks, as long as they have imports, exports, as long as they have trading partners, then the countries of the Earth have all the leverage they need to sort of turn the screws to get them back in line. Chris found the comet. That's awesome. Why does the tail look green? It depends on so the solar wind is hitting the comet and it's ionizing the particles that are following the comet, and that you're seeing the electrons that are coming, the photons that are coming from the particles in the tail, and it's an indication of the chemical constituents that are in the comet tail. So that's awesome though. Congratulations that you found the comet. So like different comets have different colored tails, and it all just depends on what chemicals are being released by the comet. That's amazing. And you're still able to watch the YouTube channel. That's great. Now go look at the moon. The moon should be up. It's a half moon. So you can definitely check out the moon. And in fact, you might be able to see the lunar X. I'm not sure when the lunar X shows up, but it's about the half moon mark. Visto Tootie, when will we get 3i Atlas pics from the Mars high-rise scope, or will the shutdown make us miss the opportunity and leave us all in tears? I would be amazed if after the shutdown ends, we don't get pictures of 3i Atlas from the high-rise camera. So, it was pre-programmed when the comet was at its closest point. The Mars Reconnaissance Orbiter was going to turn its high-rise camera on 3i Atlas and take a bunch of pictures, and I'm sure it happened. And so now we just have to wait for the shutdown. So, the problem that we have right now is that the people who work with the NASA missions have been told in no uncertain terms to not do one iota of work. That if they even check their email, then that could be in a violation of the shutdown. And so you better believe they're not going to do anything that could potentially have them get fired when they come back to work, because the administration can't wait to fire as many people from NASA as it can. So you don't want to give them any extra reasons to do that. So I think we'll see them. Just have to wait. James Levy, why does Capella twinkle? So Capella is a star, and that they're all the stars twinkle. And, this is sort of like a really interesting... So the reason that stars in general twinkle is because you've got the atmosphere between you and the stars, that there is 100 kilometers of atmosphere that you have to look through. And it's kind of a miracle that we can even look through it at all. Like, imagine if you're at the bottom of the ocean and trying to look at the stars. Just that, atmosphere, air is more transparent than water is. And so what you're seeing is that essentially the light rays are passing through the atmosphere, and then you've got different temperature gradients and wind is moving things around, and that's causing the light to take a slightly different pathway to you as you're watching the star. And so the star is kind of almost like twinkling, like changing its position, because it is sort of moving around in the sky depending on, on what the atmosphere is allowing. And so we have really powerful telescopes that are able to counteract the atmospheric distortion. They fire a laser out into space and they create an artificial star that they know exactly the shape and the brightness that the star is supposed to be. And then they modify the shape of the telescope to counteract, to essentially reverse the changes that they're seeing for this artificial guide star to make it crisp and clear again. And then anything that is in the field of view very close by will also be seen as being very crisp and clear. And that's how adaptive optics works. And then the other thing that's kind of interesting is that the planets tend not to twinkle in the way that the stars do. And the reason is because the planets are actually little disks. They're not points the way stars are. And so if you think about like a disk, right? A disk is going to be, it's still moving around, and planets do twinkle a little bit, but you can imagine that parts are still in the same spot, are still illuminating from your perspective on this little disk that's moving around in the sky. While with a star, it's just this point, and the point is moving around. And so planets don't look like they're like an easy way to spot a planet is that you're looking for the stars that aren't twinkling. Thanks for the donations, guys. Mr. Proxter, when the sun sets on the moon, is it almost instant darkness? Yeah, that's a great question. This is the first time I've ever had that question. But yeah, so you can imagine you're standing on the moon and you're seeing the sun in the sky, and the sun is not only illuminating your eyes, but then it's bouncing off of the ground, it's bouncing off all of the mountains around you, and so you're getting this reflected light, and so everything is very bright. But then as the sun goes below the horizon, then everything gets much darker, but you're still going to have some sunlight on the peaks, on the mountains that are around you, and then you're going to get the reflected light from that that's going to keep things bright. But then the sun will go so far below the horizon that even the mountain peaks are no longer illuminated, and then everything will get super dark, and it is very quick. So I talked to an astronaut one time about a repair mission they were doing on the International Space Station, and they were in sunlight, but the space station takes 90 minutes to orbit around the Earth, and so it goes into the Earth's shadow every 45 minutes. And they warn the astronauts every time that this is about to happen, because it's a very quick experience. Suddenly, you're running hot, you're in full sunlight, your radiators are running full bore to try and keep your spacesuit cooled, and then you go into the shadow of the Earth, and now it's extremely dark. You need all of the lights that are on the outside of the station, your lights on your camera, and you're plunged into this coldness. And suddenly the heater kicks in on your spacesuit, and now it's trying to keep you very warm. And he was describing it, that it's such a bizarre experience, that you're toasty, you're too hot, and you're sweating, and then suddenly you're chilly. And it's just like a light switch when you go from sunside to darkness. Cave Bear, what do you make of the Quasar redshift dipole as reported by AK Single on August 29th, 2025? Whoa. That's a deep question. You're going to need me to dig deep. So, the Milky Way is moving through the universe, and astronomers can measure the actual rate that the Milky Way is moving compared to the cosmic microwave background radiation, based on looking at the redshifted light coming from the cosmic microwave background radiation. So you look in one direction, and one hemisphere, and the cosmic microwave background radiation is redshifted a little bit, and then you look in the other direction, and the cosmic microwave background radiation is blue shifted a little bit. And so that indicates that the solar system that indicates that the Milky Way is moving through the cosmos. And I forget the exact number. It's like 650 kilometers per second ish is sort of the speed that the Milky Way is moving through the universe. Now, obviously there's no like this is just relative to the cosmic microwave background radiation. If you can imagine, there's like this giant sphere, all of this cosmic radiation was released, and then, parts of it are impacting the Milky Way sooner than other parts of it, because the Milky Way is moving. So astronomers thought, okay, are there other ways that we can measure this motion of the Milky Way through the cosmos? And so one of the things that they looked at was the light coming from distant quasars. And so they sort of measured the average redshifting that's coming from all these different quasars that are around us. And they detected another red shifting, blue shifting, but it's not aligned with the movement of the Milky Way through the compared to the cosmic microwave background radiation. And it's about 4 times greater than the speed detected by the cosmic microwave background radiation. And it's aligned with the center of the Milky Way, which is super weird. So, what does this mean? Well, it could be wrong, right? It could just be a measurement error. And so, quasars are notoriously difficult things to measure. And so I'm sure that plenty of people are going to have concerns about that. Or it could be that our understanding of our movement through the universe compared to the cosmic microwave background is wrong. The hint is that it's aligned with the center of the Milky Way. Isn't it weird that this motion happens to line up with the Earth, with the solar system in the center of the Milky Way, that there was probably some other factor. Maybe the gravity of the Milky Way is affecting the light coming from the quasars or something. It's a paper. It's very early days, and I'm sure people are going to have all kinds of opinions about it. So that's me being a journalist. Oof. Shane Loader, do you think it would ever be possible for an international moon base to be built to encourage Shane Loader, do you think it would ever be possible for an international moon base to be built to encourage cooperation between the USA and China, as ISS has been for 25 years between the US and Russia? Do I think it would be a good idea? Absolutely. I think that building a base on the moon is an incredibly complicated and expensive affair. It's going to require expertise from many nations, and it's going to be probably too expensive for any one nation to pull off. So international cooperation is the right move. It's part of the reason why the International Space Station got built and was so successful, because the Russians had a tremendous amount of experience in spaceflight. NASA had experience. There were other nations, Europe, Japan, Canada. They all came together and they built this station. And the same thing would work well with the moon. And, we have an international base in Antarctica. So this is a very common way to approach this kind of thing. And it would really help with international cooperation, that these different nations could work together. Will it happen? I don't think so. I think, part of the problem is that there are all these rules and regulations about how U.S. firms are allowed to work with Chinese firms when it comes to aerospace. There's all these sort of security regulations. And so there's no way that you could make that happen without untangling all of that and building an entirely new set of regulations. And I don't think the Americans really would want to. And so the Chinese are bringing in different partners. So there was a Pakistan astronaut going to the Chinese space station. They're bringing on sort of more international partners who are going to be flying with them. Who knows? There might be a collaboration between India and China. So I think right now there's no reason to believe an international cooperation would happen. But I think it would be a great idea. Billions and billions of stars. Did you see Comet Swan yet? No, I saw Comet Lemon. I haven't tried to see Swan. I haven't tried to see Swan yet. Where are we at? 6 o'clock. Okay. Cooper, what is the evidence for cosmic inflation? So cosmic inflation is really a fix to the problems with the Big Bang. So, when we look out into the universe, we see galaxies moving away from us in all directions. So we imagine this time when the galaxies were closer together. And eventually we imagine this time when the galaxies were all so close together that they were like the interior of a star. And you would expect then that you would see nucleosynthesis, that you would see various atoms of hydrogen and helium would be turning into, you would imagine the ratios of hydrogen to helium if the entire universe was like the interior of a star. And that's what we see. And the cosmic microwave background is, you would imagine there was this time when the entire universe was like the surface of a star, and finally light could be transparent and move out into space. And it was like, finally, we see the cosmic microwave background, which is like evidence that the universe was closer together in the past. And so we can then sort of imagine a time, less than a second after the beginning of the universe, when various fundamental forces were all combined together, that electromagnetic force and the strong force and the weak force were all one force. And these have been able to be mimicked in the lab. And so we've got all of these independent lines of evidence that the Big Bang is sort of like a comprehensive explanation for the sort of the state of the universe that we see today, and the evidence of how the universe looked in the past. But there are a bunch of problems with the Big Bang that we see places on the left side of the universe that are the same temperature and density as on the right side of the universe. Places that should have been shouldn't have been able to, or should have been in contact with each other for long periods of time. There's like predicted magnetic monopoles that should exist in the universe. And then there's like the flatness of the universe, sort of like the topology of the universe. And these would not be explained by the Big Bang. And so these were considered like the flaws in the Big Bang. And while the rest of the Big Bang holds nicely, these are sort of glaring omissions. And so back in the 1970s, a researcher named Alan Guth said, well, maybe there was a time right at the very beginning of the Big Bang when everything expanded very quickly. And that would explain the topology of the universe. That would explain how parts were not able to communicate with each other because they were torn apart faster than they could. Or is it that's how places that could be far apart were in contact once? That's right. As well as the lack of magnetic monopoles. So it was like an additional set of, it was an additional time at the very beginning of the universe that then explained the shortcomings of the Big Bang. And, so far we have no direct evidence of cosmic inflation, but there's like hints of indirect evidence that have been found. Probably the thing that will be really the smoking gun is if people can detect primordial gravitational waves, where you've got these gravitational waves left over from when the Big Bang happened, like within that first fractions of a second. And that would sort of provide us more evidence that cosmic inflation likely happened. But like, if cosmic inflation is true, then it has some really weird implications because it pretty much demands a multiverse. So there's a lot of stuff that gets super weird if cosmic inflation is true. But, the universe is what it is. Santiago T. Fraser, if we manage to establish human colony in a place like Titan in the far future, would the radiation from Saturn be lethal for humans? No matter where we go in space, the radiation is going to be a gigantic problem. And, you've got just the cosmic rays, you've got the solar storms, radiation coming from the sun. And then if you're close to Jupiter or Saturn, you have the trapped radiation in their magnetospheres. Jupiter is really bad. Saturn, I'm not sure if Titan is located within the radiation belts of Saturn, but Titan at least has a fairly thick atmosphere that would block a lot of the radiation particles, but you're going to have to live underground. That you're going to have to live under at least a meter of ice to protect yourself from space radiation. So enjoy living in ice tunnels on Titan. Ciencia Calva, do you take time to fight misinformation and negativism with people who follow these trends? Not really. There are a lot of channels here on YouTube who will go after anti-science people. Professor Dave Explains is probably my favorite. There's Simon Dan, and there's a bunch of others as well. Angry Engineer, something like that. Godless Engineer. Anyway, there's a bunch of channels that do a really good job of debunking pseudoscience or people who are grifting. And I cheer them on for their work that they're doing. But it's not the kind of work that I like to do. I think that we have to choose how we want to spend our time. And the one possibility is you can spend your time in hand-to-hand combat with the people who are spreading pseudoscience and grifting. And that's important work. And then I think you can spend your time sharing honest, real scientific discovery with the people who are genuinely interested in that. And I think in the beginning, it's really fun to watch people dunk on people who are disingenuous. But after a while, it just gets kind of exhausting and it's depressing. And so I don't want to do it. And I don't even really like watching it. At this point, I just want to share interesting stuff about space with people who want to learn about space. And I think that, if you sort of imagine it's your Thanksgiving dinner and you've got your family's around the dinner, and right now the flat earther is the drunk uncle who's yelling really loudly to get attention, but we can ignore him and continue our interesting philosophical conversations about other stuff that really matters. And eventually he'll pass out and go to bed. And I think, to kind of torture that analogy, I love talking about space and I love science, and you love listening and looking pictures of space and finding out more about the universe and satisfying your curiosity. And so we have a connection that, you want what I'm selling, and that I think that dunking on anti-science people is sort of it's a very, in dire straits, it's a heavy fuel. It's a dirty fuel for me. And I don't think it kind of has the staying power. It wouldn't keep me entertained as a science communicator if every day I was like, who am I going to fight today? Which target am I going to go after today to try and resolve their scientific nonsense? And, Professor Dave Explains he's a machine, right? But like, he's got to feel sad. Like, I don't know, he's made of steel or something. But, and also he gets his palate cleansers, right? He goes and interviews a bunch of scientists and takes time providing information about chemistry and things like that. So that's great. And I'm sure that's what he enjoys. And that's what I enjoy, right? And so, but at the same time, the thing that brings in the views is when he goes and takes on flat earthers. And I derive no entertainment from that at all. And so it would be just misery to have those kinds of conversations. So for me, I just want to share fun about space, science, astronomy, science, exploration, and I don't spend any time debunking nonsense. Ed Skeptic, can anyone buy James Webb Telescope time? You can't buy it, but anyone can get time on James Webb. You just have to make the science case that the research you want to do is good. So every year, the steering committee puts out a call for proposals, and then people write up their proposals for what they want to research. And then the steering committee looks through it and allocates time on the telescope. And you don't have to pay. It's just, you can come from any country in the world. It's free to use, and you just have to make the science case that it's going to be better for humanity if, they allocate time on the telescope for what you want. So amateurs have absolutely gotten time on James Webb or collaborated with other researchers. It's a, and this is the same case for all of them. Hubble, a lot of the major observatories, you're making, you don't pay them to use their observatory. You make the case that the science you're wanting to do is valid. Christian Desaillier, I'm interested in hearing your take on Reflect Orbital's plan to reflect sunlight back to Earth at night. How bad would this be for astronomers? So I haven't reported on this story specifically. I did do an interview with somebody who was proposing something similar, where you could reflect light off of space satellites and then use that to provide power to stations that are really far north, or give you a little bit of extra time on your solar power generators. There's like a million downsides. You are like you're illuminating a city. You're causing problems to wildlife. You have to launch these gigantic, expensive space satellites that are going to be reflecting sunlight. So they don't seem very feasible to me. Like, I can't wait to be proven wrong, or maybe I don't want to be proven wrong on this one. Yeah, they'll be bad for astronomers for sure. But the mission that I was looking at, they didn't give you a lot of time. It's not like you can have permanent mirrors that are shining down on your solar panels or illuminating your city all night long. You only get like a few extra minutes a day. So at a time when telescopes don't work that well anyway, you want to wait for astronomical dark. Avro Third, will we be more vulnerable to solar flares during pole shifts? Yeah, theoretically. So we don't know how long a pole shift takes. We know they happen every 800,000 years or so, and we don't see any mass extinctions in the fossil record that are lined up with when pole shifts have happened. We know when the pole shift happened because you can look at the magnetic crystals in lava flows, and that they align with the pole, and then you can see another lava flow and they're the opposite. And so between those two lava flows, the Earth's magnetic poles flipped, and we see the poles flip on the sun. So we know this happens. And we don't see mass extinction, which would be very unnerving if we see we see the poles flip and then we see just a million dead animals in the fossil layer at that point. But we don't see that. So chances are the Earth will be more vulnerable to cosmic radiation and to solar flares, but that this time of flipping, it might be even instantaneous. Like, it just takes a few weeks and then suddenly the poles are completely flipped over. So we don't know exactly what happens during that period. But we are overdue for a pole flip. Like, I think we're 1.3 million years since the last one, and they happen every 800,000 years. So it's time. But that's just an average. Tiago Moretto, comparing our sun's solar system to a brown dwarf solar system, will time pass faster for us? Will there be a significant difference? So, if you're really, really close to a gravitational body, like a supermassive black hole, like in the movie Interstellar, then time passes more slowly. Clocks tick more slowly for you when you are close to the gravity well than the people who are farther away. But you have to be really close, and the gravity has to be really strong. And so the difference between the sun and a brown dwarf would be measured in nanoseconds over centuries. So you wouldn't notice. Unless you're like a human atomic clock, and then maybe you would notice. But there's sort of a cool idea for the Fermi paradox that people said, well, maybe the reason why we don't see aliens is because the aliens have realized that the best place to live is huddled up really close to the supermassive black hole at the heart of the galaxy. You get all of these advantages when you're in this highly relativistic, time dilated reference frame. So when you're really close to the supermassive black hole, then the clocks are ticking more slowly for you. And so it causes radiation to be more blue shifted. So you get access to higher radiation, higher energy radiation. The downside is that the rest of the universe evolves much more quickly while you're sitting there comfortably beside your supermassive black hole. But it might be that we don't see any aliens because they've all moved right beside the supermassive black hole, and then they live in this time dilated reference frame that we can't really interact with them in a reasonable time frame. Thomas Starkey, if Plato and Habitable Worlds Observatory are able to locate and analyze a selection of Earth-like planets around sun-like stars, what will be the next decadal science objective to learn more about these stars? Well, I think that, if Plato is already going to be operational 2028, I think, so just a couple of years. Habitable Worlds probably won't get built until the 2040s. And it's going to have two jobs. One is that it's going to characterize the exoplanets that we know of. And right now we don't know of any Earth-sized worlds orbiting around sun-like stars in the habitable zone. Or find a bunch that it will be equipped with the right equipment to be able to detect Earth-sized worlds. We need the acronym for this. Earth 2.0s, second Earths. Anyway. And so that will generate new scientific questions that then the scientific community will want to put on their decadal survey. But we're, 5 years away from the 2030 decadal survey where, probably astronomers are going to put the same thing. They're just going to go check the 2021 because our priorities are not changed. We want a mission to Uranus, we want an Enceladus orbitolander, and we want the Habitable Worlds Observatory, please. And because none of those things have been built. So that's probably what will go into the next decadal survey as well. PTCP, what about the ELT in Chile? When's it coming online? 2028. So we're about 3 years away from the extremely large telescope. After the third, what is your favorite cosmic event that you've witnessed and why? Probably Comet Hyakutake is probably my favorite. Or the total solar eclipse of 2024, which I was in Texas to be able to watch it. And that was the first one that I've seen full totality, experience the whole thing. That was, a total solar eclipse is my favorite event. Chris Nelsonels, do interstellar objects lose velocity when passing through the solar system? If so, could there be interstellar objects in orbit around the sun? What's the likelihood of that? So interstellar objects can lose velocity, but only if they have a three-body interaction with some other object. So if they happen to get so close to Jupiter and its moons that they get there, it gets its orbit significantly tweaked. Apart from that, no, the comets enter with a certain velocity and then they fall down the gravity well towards the sun, and then they climb out of the gravity well and they exit the solar system with essentially the exact same velocity that they had when they entered the solar system. It's sort of like a momentary speed up and then they come back out and the way they go. But, depending on the velocity, if the comet was moving very slowly compared to the solar system when it fell in, then it would be a lot easier for it to be captured. And there's almost certainly objects that are within the solar system that are captured interstellar objects. There's been a few that have been theorized. Like I think there's like one of the moons of Jupiter is orbiting in the wrong direction. And one theory is that maybe it's a captured interstellar object. So, there's almost certainly some objects that are captured. It's just, we don't know which ones they are yet. But that would be an amazing opportunity, right? Like if we found the one that they could actually do analysis of the chemicals on its surface and realize that it's 9 billion years old. well, everything else in the solar system is exactly 4.6 billion years old. That would be mind blowing. It would be revolutionary for us to be able to learn, bring samples back home of this object that was formed in another star system. Okay. So NorCal Pacific, why are only negative matter particles sucked into the event horizon from quantum entanglement, creating Hawking radiation? Shouldn't it be a 50-50 ratio of positive and negative matter particles? So did we publish so about 3 weeks ago, I went and did my sort of exhaustive breakdown of sort of how Hawking radiation actually works. So you should go back through a few of the question shows. I apologize, I don't know which one it was, but I sort of went through how Hawking radiation really works. And like, I wish I could provide you the reference right now, but it's probably within the last 5 episodes, and that should give you your answer. Biggles Tintin, would a fusion reactor enable deep space exploration more feasibly? If not, what other propulsion systems are being considered? So yeah, like fusion would be amazing. But right now, obviously, we're having a hard time getting fusion to work at the largest scale in giant power plants here on Earth. So having a fusion reactor that's going to work in space is going to be tricky. Now, there are some fusion reactor concepts that might actually work in space, and we could develop them more quickly. They're kind of a dirtier version of fusion. And I've done interviews on the channel with people who are working for some of those companies. So if you do like a search on my channel for like fusion rocket, you should see some of the interviews that I've done. And there are a lot of really interesting propulsion ideas. I mean, not just, fusion would be amazing, but even a fission rocket would give you much faster flight times to go to other planets and out into the outer solar system. Laser sails, magnetic sails, electric sails. There's a lot of different propulsion systems that have been proposed. The problem is that a lot of the time, the space agencies are very conservative. They want to go with tried and true propulsion systems. Like ion engines weren't tested in space until the Deep Space One spacecraft back in the late 90s, early 2000s, 99. So, even like up until that point, it was only chemical rockets. And so now we have people testing solar sails. People are, obviously ion engines have proven to be very reliable ways to move. So, fission rockets have been tested on Earth, and we know their work. So it's just a matter of someone actually putting one in space. But right now, a lot of that technology is sort of on hold while NASA goes through its current reconfiguration. Aaron T, what if DNA is basically a von Neumann probe? It's a very bad von Neumann probe. So sure, like what if that there was like a spacecraft and it was carrying DNA, and the DNA landed on a planet, and then the DNA evolved into a new life form, and then that life form developed technology, and then it developed space exploration and robots, and then it carried itself to another star system and then deposited DNA. It's a very slow way to go about this process. So, the idea of panspermia as well. So you can imagine faster ways that you could try to explore the entire galaxy. And of course, if you're going to send out the spacecraft and you're not going to be around for the answer, you want it to go really quickly. Like if you sent self-replicating spacecraft to various star systems, you could have the entire Milky Way mapped out in about 1 million years. If your spacecraft are traveling at 10% the speed of light. If you have your spacecraft going at 99% the speed of light, then you're mapping out the entire galaxy in 100,000 years. So even less, 60,000 years ish, 80,000 years. So, it's if it is like life, technology turning back into life, turning into technology, that's going to take you hundreds of billions of years to pull that off. Sandwiches. If I was midway between our galaxy and the nearest other galaxy, what could I see with my naked eye? Right. So let's imagine that you are floating in space midway between the Milky Way and Andromeda, and you're in a spacesuit. So what can you see? Now, we can see Andromeda with the unaided eye from the ground here, at my house. So you could definitely see Andromeda, but it would look like this sort of fuzzy cloud in space, but there wouldn't be any other stars. So it would be very obvious. And then you could look in the opposite direction and you would see this fuzzy cloud, which is the Milky Way. And you would probably see the Large and Small Magellanic Cloud, which would be separate clouds that would be away from it. And then you would also be able to see the galaxy in Triangulum, M34. Those would be obvious. Like you look around, you'd see those 5 objects. And then there's a few other galaxies that are considered to be like just barely visible. Some people have claimed that they can see them, but if you're in perfectly dark skies in deep space and there's really no stars around you that you can see, then you would possibly be able to see a few other galaxies in the vicinity. I don't know what the third closest galaxy is. Let me find out. So the nearest galaxies, I don't know what the third one is. Oh, it's going to be a whole bunch of dwarf galaxies. Come on, give me something normal. Outside of the local group. This is not helpful. Come on, Wikipedia. NGC 300. Okay. And it is 6 million light years away. Okay. So it's magnitude 9. So you wouldn't be able to see it. Okay. So the next brightest galaxy is going to be magnitude 9, which is going to be well below what you could see with the unaided eye. So you wouldn't be able to see it. So that's it. Infinite Monkey. Would civilization have been able to recover had Infinite Monkey. Would civilization have been able to recover had Shoemaker-Levy 9 struck Earth? Let me just find out how big Shoemaker-Levy 9 was. How big an object was it? 1.8 kilometers. So Shoemaker-Levy 9, this was the comet that crashed into Jupiter in 1994. Yeah, in Jupiter in 1994. Was about 1.5 kilometers across. And when you think about, say, the comet that killed the dinosaurs, the asteroid that killed the dinosaurs, it was about 10 kilometers across. So an object that is 1 kilometer across or larger is sort of generally considered to be an object that's going to have a global impact. 300 meters and up is going to have sort of a influence on a hemisphere, a continental scale, and then below that you're going to have damage on a regional scale. So it would not wipe out life on Earth. It would probably deliver a catastrophic blow to sort of our modern technological society, but I don't think it would wipe out humanity, but it would be very bad, so be glad that it hit Jupiter, not Earth. Let's see. Ed Skeptic, I'm wondering how big Tunguska was. It was 60 meters, I think. Tim Pointing, how does one prove that these interstellar objects are indeed interstellar? Couldn't Oort cloud objects have orbits that have been perturbed by multiple large objects, resulting in a hyperbolic orbit? The problem is just how quickly they're coming through the solar system, right? So like 3I Atlas was entering the solar system at 58 kilometers per second. That's ludicrous speed. So much faster. Like the Earth is orbiting the sun at 30 kilometers per second. There's no sequence of events that you could coordinate that would cause an interstellar object to move through the solar system at that ludicrous speed. Now, if it was moving at 5 kilometers per second, maybe, and then, you know, obviously accelerated as it gets closer and closer to the sun and then back out again, you could imagine that maybe there was some kind of event that a comet fell down 1 million years ago, did a flyby of Jupiter, got a gravitational assist, flew out really far, and then is coming back in. But 58? No, it had to have come from outside the solar system. Jamie Doe, do you think our technology is advanced enough to detect alien technology, given how limited our knowledge of the universe is? We don't even, for example, fully understand fundamental forces. So, like, this is going to be a very circular answer to your question, which is, like, do we have the ability to detect the presence of an alien civilization? Only if they are giving out signals that fall within our ability to detect them. So, you know, the deeper question that you're asking really is, do we think that alien civilizations will give off the kinds of signals that we would be able to recognize, or will they have shifted to some other method? Will they be communicating with neutrinos or communicating with gravitational waves, or will they exist in some kind of transdimensional hyper existence that we can no longer detect? And the answer is obviously we don't know. We've never done this before. We've never confirmed the existence of another civilization. We don't know how they tend to roll. But you know, we sort of have to fall back on this assumption that we live in the universe is matter, the universe is energy, and then if there's any other civilization, they evolved in the same universe that we did, that they had the same kinds of constraints that we do. They're dependent on the light coming from their star. They're dependent on the matter that their planet is made of. And so then they would have made technological choices and a technological evolution that's kind of similar. They would use energy and turn matter into useful things. And that any time you use energy or turn matter into useful things, you're giving off a signature into space. And so we would hope that we would then detect the presence of that it would be done at such a scale, be like, whoa, look at them siphoning that energy off of their star. Whoa, look at them configuring matter into shapes that matter doesn't naturally tend to turn into. These are the kinds of things that we would expect to see. The fact that we haven't seen them so far, either we just haven't spent enough time looking, or that we're, you know, not tuned to the configurations that they are using energy and matter for. But, you know, I think that the other, you know, if we knew that there was another civilization out there that was maybe less technologically advanced than we were, I think there would be a big interest in sending out some kind of signal that they could understand. And so we would hope that other civilizations out there would take pity on us and go, look at those poor monkeys who think that they're alone in the universe, or they're wondering if they're alone in the universe. Let's throw them a bone and let them know that they're not alone. That would be very helpful. That'd be very kind for them to do that for us. And I hope that, you know, that's a thing that we will do when we discover some other civilization out there. Or maybe it's just going to be the prime directive all the way down, that we won't interfere with them. And so maybe the aliens are waiting for us to develop our warp drive before they let us know that they exist. Is it that one? Church discography. Could an aquatic species ever become spacefaring? I mean, there's no physical reason why an aquatic species would not be able to become a spacefaring civilization. They just have other challenges. If they are, if you could imagine that there was humans, right? And we lived in the ocean, but we were curious and we were intelligent and we were developing our underwater technology as best we could, we would start to have ideas. And so you can imagine that, for that civilization, their first concept of space exploration is literally to get out of the water, to be able to get out of the water and survive. And then realize that you're in a different kind of fluid. You're in an atmosphere and you have to be able to survive in that atmosphere. But eventually they'll learn to do things outside in that atmosphere and be able to build equipment and be able to go to space. So yeah, I mean, and in fact, I don't even know if it's like that much of an I don't know if it's that much of a delay. Like maybe they need an extra few thousand years to develop the technological infrastructure to work in outside of the water with their wetsuits and reverse wetsuits and the reverse submarines. I don't know, walking submarines, what water cars, whatever they would have to do to build a technological civilization to get access to the resources and then be able to go to space. So yeah, I don't think there's any fundamental reason why. There's a lot of, if you're intelligent and you really want an outcome, then you will come up with ways to achieve that outcome. And they may be very difficult, they may be very time consuming, and they're going to be risky, and they're going to require a lot of out of the box thinking, but eventually enough minds will come up with ways to accomplish these things. There's like this idea that, that you need to have a certain amount of oxygen in your atmosphere to be able to allow combustion. And then without that, you pretty much can't have a technological civilization. But there are ways that you can concentrate the oxygen, like the way a rocket works, right? Like a rocket doesn't require a certain level of oxygen in the atmosphere. A rocket brings its own oxidizer. And so you would imagine some intelligent civilization. It may take them an extra 1,000 years, 2,000 years, 5,000 years, 10,000 years, 1,000,000 years, whatever. But if the desire is there and they can see the reasons to do it, I think they'll overcome almost anything. I love the question though. Like it's a very sort of similar question is, people say, well, you can't have an advanced civilization without multicellular organisms, right? Like we had bacteria, and then 500,000 years ago, we got multicellular organisms, and then that led to animals and technology and so on. And so without that jump from single cell to multicell, but like, who's to say that we couldn't get really interesting emergent properties coming from single cellular organisms working in colonies at some vast scale? We see some hints of this already, that you get, you can have a whole bunch of bacteria that are all living in a colony, but, they are starting to turn themselves into certain forms as befits the needs of the colony. And so you can imagine more and more sort of larger, more complicated organisms arising out of large clusters of single-celled organisms that are achieving some kind of emergent behavior. So, I've actually directly asked this question to biologists, and they're like, yeah, I mean, there's no reason why life has to follow this journey of single cell, multi-cell intelligence, spacefaring. Maybe there's other steps, other pathways that this can take. So I think, we think, oh, those poor people on the heavy gravity world. Oh, the poor people who live under the ice on Europa. Oh, the poor people who live, in a water world. That's just an engineering challenge. Graham Goins, has 3i Atlas done anything recently that it shouldn't have? Not that I'm aware of. So like right now, we're not really sure what 3i Atlas is doing. It went behind the sun. So the only view that we have of it right now is coming from NASA's Punch mission and one of the NOAA satellites that it's observing the sun. Maybe some other solar satellites have got some images so far. I haven't heard of it yet. We're reporting literally every single piece of 3i Atlas news we find both on Space Bites and on Universe Today. So I can't wait for it to do something weird, but so far it's exhibiting very comet-like behavior. Alexandra, would an observer on the other side of the universe see Sag A star in its quasar state due to the amount of time it took for the light to travel there? Yeah, I mean, assuming that Sag A star has been a quasar in the past, like maybe every supermassive black hole goes through a quasar state, or maybe some black holes feed so slowly that they never go into this full quasar state. Theoretically, we could see echoes of times when Sag A star was a quasar in the past, that you can see bright spots where there's radiation moving away from the galaxy, where there was a lot more radiation happening in the past. But, and right now, astronomers don't even know how long this phase lasts. Like, does a quasar remain a quasar for 1 billion years, hundreds of million years, or does it only remain a quasar for like 1,000 years and then turn off? And does that shutdown happen very quickly? We're starting to observe enough quasars that we're seeing examples of quasars turn off and on, or turn off or turn on. And so it's looking like maybe this state is a lot more rapid. But if Sag A star, which is a 4.3 million solar mass black hole, was actively feeding on material, then it would be visible as a quasar. A collimated jet of material coming out of the quasar would be visible from really far away, from billions of light years away, to some other astronomers right now. Sid Vicious, Fraser, what are the best places on Earth for stargazing, dark skies and whatnot? I mean, obviously you just want dark skies. You want dark skies, Bortle 1. So that is, you want to be like 100 kilometers away from the nearest city. And that'll give you nice dark skies. Where I live, I can see the Milky Way from my backyard. I live in Bortle 3 skies. The best skies that I've ever seen were in Australia. I was on the east coast of Australia, north of Brisbane, and it was just glorious, absolutely amazing, better than anything I've seen here. And I've been in really dark skies, but there was something really special about the skies in Australia. Maybe it was the air was so dry, but also just the position of Australia. You get the Milky Way running like directly overhead, while for me, I see the Milky Way down near the horizon here, but the center of the Milky Way down near the horizon in Canada. But ideally you want to have a high altitude as well. So you can go to Chile, you can go to where the observatories are in Chile. You get that high altitude, those dark skies, and people have reported there. It's just mind blowing what you can see. So I would go, if you want like a vacation to really see like really nice dark skies, go to the mountains in Chile, go to the Atacama Desert in Chile, and you should have a mind blowing experience. It like sometimes doesn't rain in some of those dry desert valleys for years in Chile. So R. Gerber, how many times will they rediscover water on the moon and Mars? I mean, they have discovered it. So now it's a question of identifying all the different places where it is. So we know that there are permanently shadowed craters on the moon, South Pole. We can detect the deposits of ice there. People have been able to detect the presence of water mixed in with the regolith on the moon at various latitudes. Different telescopes are finding water in different locations. And then on Mars, we know that it is on the ice caps. I mean, you literally can look at Mars through a telescope and see the water ice caps on Mars. So you can discover it every time you just look through a telescope. But we also know that it is underground. We know that there are deposits of ice that are, farther away from the North and South Pole. We also know that water acted on Mars for long periods of time in the past. And now it's just a question of really trying to sort of reconstruct the history of water on Mars. So, it's kind of like, when will they rediscover the history of the Roman Empire? Right? Like it's done in little bits and pieces. Every time someone finds a coin, every time somebody uncovers a new building, uncovers scrolls, learns more about the history of the Roman Empire, we learn more about what happened there. And so it is this constant story that is unfolding. And it's the same thing, that we're learning more and more about the history of water on Mars and the presence of water on the moon. Web Fiji, could a comet theoretically exceed the escape velocity of the known universe? There is no escape velocity of the known universe. There's no way to escape the universe. So, there's an escape velocity of the solar system, which is about 42 kilometers per second. There's an escape velocity of the Milky Way, which is about 300 kilometers per second. I imagine there's an escape velocity of the local group. I imagine there's an escape velocity of the Virgo supercluster. I imagine there's a escape velocity of the Laniakea supercluster. Maybe it's like 1,000 kilometers per second, 2,000 kilometers per second. But eventually, there's nothing else left to escape from, and you cannot escape from the universe. Second page now. There is. Let me just get that. What are we at? Whoa, 8 minutes left. Oh, those were on the previous. Okay, never mind. Getting through a lot of them today. Feels good. Feels good, man. Feel like I'm doing my duty. Space Geek Sherry, that huge dark spot on the other side of the sun looks like a giant impact area, but I've read it's just different temperatures. Do you think it looks like an impact? I'm not sure what you're talking about. There are times when... So if you just look at the sun through a telescope, with a proper solar filter, the sun always looks almost exactly the same. That you see the surface of the sun, it's this yellow ball, and you can see sunspots. Like the only variation that you see on the sun is the presence of sunspots, little sunspots. And they are still extremely hot. They're dark regions on the sun. They're caused where magnetic field lines are piercing out of the sun. But there are different instruments that are looking at the sun. And so sometimes you see what's called a coronal hole. And I think that was done with like SOHO, and they're looking at different wavelengths, and they're observing places where essentially the strength of the corona, which is the atmosphere around the sun, is weaker in spots. And so it's not an impact. It's just that the way the magnetic field lines around the sun whip up and form the atmosphere around the sun, and you can have openings, places of less density in the atmosphere of the sun. And so no, definitely not an impact. But, we see pictures of the coronal hole all the time, and unfortunately this gets used for people making stuff up on the internet. So people will take this picture that shows the coronal hole, and sometimes it's like different shapes, like there's a heart-shaped one, and be like, and then they'll just literally make something up on YouTube. Michaela Soul Speed. Let's say we find a perfect second Earth. It has plants and sea life in its oceans, but no land life. Would it be okay for humans to colonize that world? So, like, let's imagine that this is a world that we find in another star system, right? And we've sent I don't know, some colonization ship to this other solar system. And they go into orbit, and then they look down and they're like, well, the land is barren. We don't see anything on the land, but we can see that there is whales and life forms in the ocean. Like, you wonder, like, why is there nothing on the surface? Like, what's going on? That sounds like a trap. But if, I think they would do it anyway because there's nowhere else to go. It's either that or die. And so they'll go and set up shop on the surface of that planet, and they would take their chances. Now, you would, probably, like, there's a whole bunch of sort of ethical issues, even sort of considering this, which is that, when we go to some other world, and if there is an indigenous species that already lives there, then we're going to be introducing our life forms, and not just ourselves and our pets and things like that, but our bacteria and our parasites and our viruses and all of that kind of stuff. And that stuff is going to try to set up shop. That cyanobacteria, like we're all covered in microbes that are very hardy and can withstand radiation and being in the depth and cold of space for very long periods of time and still be able to thrive and survive on Mars or, some other world. And so very quickly, our microbes are going to do battle with the microbes on this other world. And if they came from completely different evolutionary sort of places, we see this happen here, where you will have an invasive species. You'll bring rats to Hawaii, and the birds on Hawaii had no protection against rats, and so they just got wiped out. So we know that invasive species can be a big problem, and so we're going to bring the stuff along with us wherever we go out into the universe. And I think that we need to be really, really careful. We do a really good job of analyzing the environments of other planets before we try to set up shop on those planets, because we just, like, there's so much science that can be done to understand and study these other planets, that we can learn so much about them, about the history of life, how life formed on a completely separate world, a completely independent evolutionary process. Like, that could keep scientists busy for centuries. But people are going to want to just live there and build our cities and start to pollute. Even if we never interacted with them, we tried to really respect them, our bacteria aren't going to do that, and they're going to set up shop and they're going to go to work. So I think, no matter where we go, we have to be really careful. Any environment that is even potentially habitable, like Mars, like Europa, like Enceladus, we have to be super careful about how we explore those places, because we could pollute them with our life and then muddy the answer about how life formed independently on some other world. Don't remind us how germy we are. Like, not you specifically. No, we're all super germy. What is it? We have more cells in our gut than we have cells that, more bacteria cells in our gut than cells in our bodies. So we are literally just a spacesuit for gut microbes. All right, we've reached the end of our hour, 2 hours. So thank you, everyone, for hanging out with me. I really appreciate it. I really look forward to this every week. Now, I'm going to be traveling next week, so I won't be doing a live show next week on time. But if our travels work well, we've got a good Airbnb, I will try to reschedule and maybe do something just live and surprise live stream. But I'll let you know. But we're going to probably run some overtime episodes next week while we sort of recalibrate. And I will keep you posted, as well as how things are going with the new telescope. I need a name for it. I should probably ask for a name for the telescope. Yeah. All right. Well, thanks, everyone. thanks in advance to Chad and Anton. They're gonna have to deal with this. Thanks to Zapfan for hanging out and helping categorize the questions. I really appreciate it. And we will see all of you in 2 weeks, maybe 10 days. I don't know. I'll keep you posted. All right. We'll see you later.